Hi everyone, welcome to the video. Today we are going to solve distinct occurrences. In this question we are given two strings, string S and string T. We need to return the count of distinct occurrences of T in S as a subsequence. Come to example 1, string S is banana and string T is ban. Okay, and we need to deal with subsequences. The first three characters of string S holds the string T. Okay, BAN, BAN. Again, we can take the first two characters BA and not take the first N but the second N here. This will form BAN again as a subsequence. It is a subsequence, non-contiguous, and relative position is maintained. Again, we can take the first B and second N to form a ban. Similarly will be the case for example 2. So you can solve this question using recursion, and thus I will use dynamic programming in order to optimize our solution. And at the end we need to return modulo. Okay. So first I will store this modulo value 10 raised to the power 9 plus 7. I will create two variables x and y which will hold the length of string s and string t respectively. Then comes the best part. I will create a DP. Okay. Initialize it with 0 everything, and it will be in the range of y plus 1 because we need to find occurrences of t in S and not vice versa. That is why it is of length y plus 1. Cool. Now, there will be one more condition, base condition, that if the substring subsequence is of length 0, in that case our answer will be 1. Suppose length of a string, both the string S and T is 0, they are empty. In that case, there will be one subsequence. Okay. Now, I will populate this TP for in range 1 to x plus 1 entire string S except the zeroth index because we have already taken care of zeroth index. Now, in a loop for chain range, I no, will minimum of I comma y. We will go till 1 no, in backward. Now you must be wondering why I'm taking minimum of y and I and not simply y or I. So I'll tell you, there are two, three very basic things which it solves. The first, it prevents going out of bounds when if I exceeds the length of t, okay, which is y over here, okay. There's no need to iterate over subsequences of length greater than y. To prevent index out of bound, we will restrict the inner loop to iterate up to the minimum of I and y. Again, it increases the efficiency. It will restrict the loop to minimum of I and y, which will help in avoiding unnecessary iterations. Once we reach a point where the length of the current prefix of a string s exceeds the length of a string t, there's no possibility of finding a magic subsequence. I hope you're getting a point. Again, it optimizes our algorithm. Okay. Now we'll come back to our DP. Now the main thing, if s of I minus 1 equal t of j minus 1. This sounds similar to longest common subsequence LCS. Now if the ith character of string s and mass s sorry, if the ith character of string s matches jth character of string t, the count of subsequence of length will get updated. Get updated in what manner? I'll tell you shortly. Let me first write it. What I did over here is the count is updated by adding the count of subsequence of length j minus 1 to the count of subsequence of length j that matched up to the previous character of s. Now this will ensure that we count all subsequences ending at position I that matches up to the position j. Now that we have filled our DB, I will return it. And by the way, I have also attached a Medium article link which I wrote for this question. You can go there, refer it in order to understand in a better way. So as you can see, it did the job pretty effortlessly in very less time since we are using DP and we are within well-defined time limit in this question. So I hope you learned a new concept and enjoyed it. Thank you. Have a nice day.